Today we're going to finish the last session about the Mathematic Olympiad in Belgium, the Maxi level. Today we're going to introduce 4 problems in the finals of the Maxi level. The students in the 5th and the 6th year in the high school are allowed to participate in competition on the Maxi level. So the first question is something about divisibility. Yeah, it's asking what are the digit pairs x and y such that the form 30x03 no 30x0y03 is a multiple of 13. We are requested to find all the pairs of x and y. Divisibility of 13 or by 13 is something special. Yeah. We do not have any special formulas or patterns behind that, but we know, for example, 13 times 7 times 11 gives us a product of 1001. That's something we know, but actually it's not the only products which are a little bit specific, because you see the product is consisted with only 1 and 0. So if we replace 11 with, for example, 111, and the product will be 10,101. So it's also something special. You see, the number consists of 1 and 0. If we replace 111 with 1,111, and the product will be 10, 11, and 01. They're also symmetric, they're always symmetric, and with 1 and 0. So the last step, if we replace the 1,111 with 11,111, and the products will be 10, 111, and 01. And that is what we are looking for, because comparing to our target is 30x0y03. And we know that the 10, 111, 01 is a multiple of 13. And of course, that gives us the hint. If we multiply it with 3, and then the 303 will be also a multiple of 13. And that means if we said XOY minus 333 will be a multiple of 13 as well, right? So that's what we're looking for. And it's quite easy for the follow-ups. So we replace the XOY into a calculation like 100 times x plus y. And we know the 333 divided by 13 has a remainder of 8. So then it's congruent to 8 modulo 13. Yeah. And further on, we know that 104 is also a multiple of 13. So that's why we replace 100 times x into minus 4x plus y is congruent to 8 modulus 13. So actually here, for each x and the y, we have a good combination, and the combination will give us a remainder of 8 when it's divided by 13. So let's start a table. I'm going to make more space here. So if we start the table, example, we just draw x and y. Okay. So it's clear when x is increased by 1, and the y will be increased by 4, right? But a requirement is that x and y are digits. So by nature, we have x and y is a non-negative and no more than 9 because they are digits, right? So we start with x as 0. It's quite easy. Y then is -4. So y must be 8, yeah, because -4 times 0 is 0. So y is 8. So that the congruence will be 8. So if x is 1, and then it's -4, and at the end we need remainder is 8, so y must be 12. But 12 is bigger than 9, so this is no solution. But next 2, and then y can be 3, because -8 and +3 is kind of -5. -5 is the same as +8, modulus by 13. And when x is 3, just add 4. So we have 3 and 7. And when next is 4 and +4 again, so gives you 11. But 11 is not a good one because 11 is bigger than 9. And the 5 gives us y is equals 15 now, but 15 we have the modulus 13, so give us y is 2. And next is 6. 6 and 2 plus 4 is 6 as well. And 7, we give the 10. So 7, 10 is also no solution. And 8, the next is 8. It gives us 1 because, yeah, 14 minus 13 is 1. The next is 9. And the 1 plus 4 is 5. So actually, out of the 10, the x is 1, 4, and 7 are no solution. So still there are 1, 2, 3, 4, 5, 6, 8. There's still 8 pairs of x, y, which makes these form 30 x, 0 y, 0, 3 is a multiple of 13. So that's the answer of the first question. Second one, all the students in the class are of different heights. The teacher wants to place them in a line, right? And first in the ascending order of the heights, from the shortest to the highest, or the shortest but shortest in the first half. And then in the descending order of the height, it's not necessary the highest students are standing in between, because it can be also at the end, meaning that there's the line, they are only ascending or only descending. But the first part is always ascending, the last part is always descending. And it's asking how many such lines are there. Yeah. So think about the highest or the biggest student in the class, because he will be kind of divider. For example, this one is the highest or the biggest student in class, and he or she will be the divider of this line, because before him it is a ascending order, and after him is a descending order. Yeah. So we just name it as L, okay? We name this one students as L, and we name the student before him is a set of A, because it's ascending, and the other student after him is D in the set D. So actually S, it will say S is all the students like N students. So the size of n is n, example. And now we know L is only 1, right? L is 1. And then it's one student. L is the one student, the highest student, the highest. Yeah. Okay, the highest. And we know for the rest, A and D, right? The A and D belongs to a set where all the elements are coming from S, but not L, right? So actually the A plus D is a set where the coming from S, but not equals to L. So no L, but all the others are belonging to the set A plus D. So that means here it has M minus 1 elements. Only L, only the biggest students or the highest or tallest students is out, right? So M minus 1. And we see that A and D is actually a pair of complementary subsets of these data of these sets, right? Of these sets. And for A, it's always ascending. So for a given group of A, the order of these students, there's only one arrangement. There's only one way of arrangement. And for D, for a certain set of D, it is always ordered in the descending order. So that's also only one way of arrangement. So this question is asking how many such lines is actually is equivalent. The number of lines is equivalent to the number of different A's, because D and A are a pair of complementary subsets. So A and D is actually a kind of bijection. Bijection is one-on-one relationship. So if we find the different A's, different subsets of these sets, and then we find already the number of A's. Since this set has n minus 1 elements, then the number of subset is actually 2 to the n minus 1's power, right? Because for each element, there are two ways to join A or not join A. So for each element, there are two ways. So that's in total for n minus 1 elements. In total, there's 2 to the n minus 1 power of different ways. So 2, the n minus 1's power of 2 is the answer. Is the answer. Of course, including the empty subset, because empty subset stands for L stands as the first one. So that's first in the row or first in the line. So that's only descending order. Yeah. If A is the full set, A is the full set, meaning D is empty set, that means the L stands at the last in the row. And there is only a ascending order, right? So this is the answer. The n minus 1's power of 2 is the total number of lines of arrangement. Of course, you simply replace n with 3 or 4, and then you got the answer also for the question A and question B. Okay, number 3. Number 3 is it seems kind of number theory, right? And we are requested to determine all the pairs of integers x, y, such that x plus y equal to x squared minus xy plus y squared. It's a typical number theory, but here I find it's not bad idea to solve it using kind of algebraic series. So we have x plus y actually equals to x squared minus xy plus y squared. and we see it is a quadratic equation, right? In terms of x or in terms of y. So let's just write it as a standard format of a quadratic equation of x in terms of x. So we have the second order of x, and we move the x to the right. So we have minus y plus 1 x, and plus y squared minus y equals to 0. So that is the second order, first order, and the constant term. Right? And for such equation, if we want to have a real solutions, and the discriminant must be a non-negative. So we just calculate discriminant x to y plus 1 square minus 4 times y square minus y. Right? So the discriminant should be non-negative. And we just arrange it. So we get 3 times y squared minus 6y minus 1 and no larger than 0. And that is 3 times y minus 1 square, no smaller than 4. Yeah. So that is y minus 1 square, no more than 4/3. And we know that y is integer, right? X and y, both x and y are integer, and y minus 1 square will be also integer. So that's why we can just convert this y minus 1 square smaller than 1, because it is an integer. And then there's only a few possibilities. Yeah, a few possibilities. That's y is 0 or 1 or 2. Only 3 possibilities. And then we have narrowed down the range. And it's quite easy to just replace y with these possible values in the equation, and we find a quadratic equation of x, and we can easily find all the possible solution, all the possible pairs. So actually you have 0, 0, 0, 1, 1, 0, and I think we still have a 1, 2, 2, 1, and 2, 2. Yeah, that's all the possible values, possible solutions of x, y for this equation. Okay, last question. Last question is a geometric question. It's geometric question. Just see what the question stated. We were given the acute triangle A, B, and C, and B prime is a refraction point of B over the side AC, and C prime is the refraction point of C over the side AB. Yeah. And if we draw the circumscribed and circle of A, B, and B prime, and A, C, and C prime, the two circles intersect each other at A, of course, and at point P. And just connect AP, we have to prove that the center of the circumscribed circle of ABC, let's say it's O. We have to prove that O is on the line of AP. So actually 3 points on the same line, or it's collinear problem. Okay, to solve this question, I wanted to show let's say a lemma or some basic about the circumscribed angles, right? So for example, if we have a triangle ABC, okay, ABC, and assume that is the center of its circumscribed angle is O, for example. This point is O, it's the center of the circle. So we just connect each part, and the three sides should be equal. That is the radius of the circumscribed angle, right? And that's the angles 1 and 2. And here, because the AO and CO are the same, so we have also here's 1, here's 2, and angle 3 and angle 3, right? Yeah. So it's clear that the angle A equals to angle 1 plus angle 2. Yeah. And angle BOC is 180 minus 2 times of angle 3. And besides, we know for the sum of the internal angle of ABC, we have 2 times angle 1 plus angle 2 plus angle 3 gives us 180. Yeah. So by this we know, okay, the BOC is 180 minus 2 times angle 3. So this is actually 2 times of angle A, because it's easy to replace this part into the equation, and we find the 2 times of angle 1 plus angle 2, which is 2 times angle A. So that means this angle is always twice of angle A. And that means if we have a point in the perpendicular bisector of BC, where the point has angle like BOC, this angle is 2 times angle A, and then this point must be the center of the circumscribed angle of ABC. So that's the only point, only angle, because otherwise you find another point, and for example, in this case, this angle will be smaller than 2A. If we have a point below this O, and the angle will be larger than the 2 times A. Okay, so then we come back to the question itself. Let's make some space just to write something. Okay, just clear it. So we have a so-called refraction, and start with, we take the B and B prime, for example. The B prime is a fraction point of B over AC. So that is clear. The AB B prime, so this is this angle, AB B prime equals to it's equals to A B prime B, right? Because it's really a refraction. It's really a refraction. And here we have a right angle. So if we still name it here is angle A, and the both angle B equals to angle B prime, and equals to like 90 minus angle A, right? 90 minus angle A. Yeah. And since A, B, B prime, and the P, the 4 points are cosecant, or they're on the same circle, and the angle B prime is equal to angle APB, right? Because they're facing the same chord of AB. they're facing the same chord of AB. So that's why the inscribed angle B equals the inscribed angle ABB. Yeah. So then we have the same. We have the same similar for the C and C prime. So we have also the angle C equals to angle C prime, which is also 90 degree minus angle A, and where the angle C prime equals angle APC. And that means these two angles are equal. Yeah, all the angles in gray are equal to each other. Yeah. So that's the first step. Now, how to get the point O? So I said in my solution, I first draw a circumscribed angle of the triangle PBC. So I draw the circumscribed and circle of triangle PBC, and let O is the intersection point of AB, and the circumscribed angle of BBC with AP, right? So with AP. So I let the point O is the intersection point of the circle and AP. Yeah. And now the next step is say we have here actually because O, C, P, B are cosignic. So the 4 points on the same circle. So that means we have the opposite angle are supplementary. So the angle BOC plus angle BPC is 180 degree because the 4 points are on the same circle, so they are supplementary. And we know that the APB is 90 degree minus A, and APC is also 90 degree minus A. That means the BPC, the angle BPC is twice of 90 degree minus angle A, and that is 180 degree minus 2 times A. Yeah, and combined with these cosignic conditions, we can make a conclusion the angle BOC equals to 2 times of angle A. So that is the first condition. Second condition, we see the OC is the chord. OC is the chord of this angle in the red circle, and BO or OB is also chord of this angle. And we know these two gray angles are equal to each other, right? The two gray angles are equal. So that means the OC also equals to OB because the inscribed angle are equal, so the chord are also equal. That means O is on the perpendicular bisector of BC, right? Because OB equals LC, so O is on the perpendicular bisector of BC. And together with the BOC, it's 2 times of angle A. So O is the center of the circumscribed circle of ABC. So that's what we got from the lemma. Okay, so that's the end of all the Belgian Mathematical Olympiad finals this year. And actually, it's called the Belgian Mathematical Olympiad, but it's only applied in the French-speaking regions of Belgium. And in 2 weeks, we'll have the finals of the Flemish part of the Belgium. So it's called Junior Wiskunde Olympiad and Vlaams Wiskunde Olympiad. And by then, we'll have again several interesting problems to be introduced. Okay, see you in 2 weeks. Bye bye.